I'm not prepared tonight.
That's all right. My computer was freezing a lot when I was trying to do the SPS stuff, so
Well,
you might be in this.
the preparation assignment doesn't look like we have to go into SPSS, but I don't know what the quiz will have us do.
Oh, I thought there was a part where we did have to do the SPS.
Part 2 has you using Excel to get the standard deviation and the mean.
Right, I did that.
Well, hang on, maybe oh yeah, it does say SPSS to do the confidence level, confidence interval.
Right.
Well, I have my SPSS up, so maybe between the both of us we can figure it out.
Yeah, for sure.
Yeah. I don't even know what questions I have about the lesson. I just know I need to do a lot more reading to understand it.
I read it and then tried to do the SPS and it kept freezing on me, so I'm like just confused from that, you know?
Uh-oh.
We'll
Well,
figure it out.
you want to just jump into the quiz and let's see how we do?
Yeah.
Let's see. I hate feeling like this. I usually feel pretty prepared, but
Well, yeah, after doing the homework, I normally feel pretty good too. I don't think it's super hard. It's just my SPSS was like freezing, so it wouldn't let me do anything. But it seems pretty easy.
okay, number 3. In previous lessons, we've assumed the population standard deviation was known. In this lesson, we're making a different assumption. What has changed? So it's unknown, right?
Yeah, that sounds right. I think that's like one of the first things they say in the lesson.
The null hypothesis is mu equals 8, and the alternative hypothesis is mu is greater than 8. Population standard deviation is not known. Becca collects the sample of n equals 9 and computes x bar equals 11 and s equals 6. Is
So
the
the
standard
standard,
deviation known? Well, it says it's not known.
yeah, because
Just seems too obvious of an answer.
they give you the sample standard deviation, but they don't. I think it said in the reading that they won't give you the population standard deviation, or that you won't know it. So I think it is no.
Okay, and then what's the value of t?
T.
So
Where's that formula? So T is so 11 minus 8. Stop me if I'm doing this wrong.
I'm looking for the formula still. You're ahead of me.
Okay, 11 minus 8 divided by.
Okay.
So
T equals
did you find it?
X bar. Is that the one you got? X bar minus mu
Minus.
divided by s divided by the square root of n?
Yep.
Okay, so then I have x bar is 11. Is that right?
Yep.
That's 11 minus 8 divided by 6 divided by the square root of 9. Is that what you get?
Yep.
Okay.
Yeah.
So that's 3
Right.
divided by.
So it's 3 divided by 2, right?
My phone is making noise. Let me see. Yeah, 3 divided by 2.
So 1.5.
Round to 1 decimal point. So that's what throws me off when it says round to 1 and there only is 1. I'm like, well, did we do it wrong?
No. So it should be just 1.5, right?
11 minus 8 divided by. 3. 6 divided by 3. Yeah, it's 3. Okay, we're just going to put 1.5. That looks right.
All right.
Okay, use the following values which were pulled from the data file body temp. Copy and paste them into the software you're assigned to use. Use the null hypothesis. Oh, if I copy and paste on the screen, I wonder if it'll go into SPSS just like that.
Yeah, that's the issue I normally have is it won't.
Or we have to type it all in.
Right.
So data view, right click, let's see, paste. Oh, it did it.
Oh, did it? Okay,
Uh-huh.
I hope you're okay with me relying on you for this part because
I
I
yes,
don't
I'm
want my
relying
computer
you
to freeze.
I'm relying on you for formulas, so we're good.
Okay.
Okay. Use the null hypothesis of mu equals 98.6 and alternative hypothesis of less than 98.6, level of significance 0.05. Okay, so then in SPSS, I want to do the t-test. Is that what I want to do?
Let me see what is the because
Well, the
the
x,
t-test will tell you the the x is, right? Because
oh
that's the
gosh, I
mean.
don't know. I'm so twisted now. The x bar is
That's the sample mean.
the
So
sample. Okay,
yes,
so
I
we need the
think
mean. Okay.
and then the s is the standard deviation.
So I want to do analyze. Move the variable over statistics. So I need the mean. And what else does it want? The mean and the variance? Is that what S is? Or no, standard
I
deviation.
think that's the sample standard deviation.
Okay, so it says the mean is 98.22,
Okay.
round to 3 decimal places. Ugh.
90.22.
Uh-huh.
Okay.
I think I have to check it in Excel just to make sure I feel okay about
Okay. No worries.
that. Come on. Okay. Okay, yes, 98.22.
Okay.
And the where'd the chart go? The standard deviation is how many decimal places do we need?
3.
Okay, so 0.922 because the next number is a 0.
Okay. T-score.
Okay, t-score. So we need to do the same thing. So x was 98.22 minus
Does it not show
the.
up on the thing what the t-score is?
It probably would if I think that's when I have to do the sample
Oh, the one sample test or
T,
whatever.
right? Yeah. So let me do that. That was that under data? Where did he go for that one? Transform,
So
analyze graphs. Maybe it was analyze. Compare
yeah,
means.
analyze, compare means,
And then
and
one
then one
sample
sample
t-test.
t-test. Yeah.
Okay, and then under test value, I need to put 98.6
Okay.
for the t-score. And okay. Okay. So the t-score is negative 1.843.
Negative 1.843.
Uh-huh. Ah, I hit that X. Negative 1.843.
Okay, cool.
Okay. And the p-value is P-value. P-value is on the same data?
Uh,
I got the degrees of freedom. That's 19. I don't know if do we need that? No.
I don't think so. I'm trying to remember how to get the p-value on here.
P-value. The mean difference. I got the significance. That's the significance level, though. That's not the same thing.
Yeah. Let's see.
Sorry, I'm
No,
a
you're
slacker
good.
today.
No worries. I'm not much better.
I'm gonna try to pull up the textbook and look at it. P-value. Okay. Okay, so on the book, when it shows the one sample t-test for means, the columns it has is t, df, and then the p-value. But mine, when I pulled it, has t, df, significance level, and mean difference.
Right. Yeah, that's what I'm looking at for like the example of what
So
it shows
maybe
you.
I should look at the, let me see. I don't know. Analyze, compare means. I did
Are
one
you looking at the
sample.
blue box that tells you?
Yeah,
Okay.
because
Yeah,
the
because I keep
SPSS
reading.
doesn't look like that for me when I'm looking at it.
How do we use the sig two-tailed output to find the p-value?
Let me see. Okay, the one down here, it doesn't have that. Okay. Depends on the alternative hypothesis. Consider each of the following. What?
So my question, were they getting the 98.6? Is that from earlier in the?
Yeah, and the question.
Oh, okay. So that's
Like, it's part of what they were looking at already
gotcha.
for the body temperatures. It's just the same as what we're looking at, but not the same data.
Right.
So our significance level on what we pulled is
Is less than the.
0.081. But 0.081 and we're probably making this much more complicated than it needs to be, but I'm just so unsure. Our question was less than, so it should be one-sided, right?
Yeah.
Our alternative hypothesis. So that means that
Yep.
we half the significance level.
Yeah, I think
That's what he said in the
yeah, I think so.
video. I don't know. Less than, adjust it so you get the error. So yeah, divide the
Yep.
sig by 2.
Yeah, divided by
So
2.
0.081 is what, 0.405?
Sounds right.
0.0405?
Point
Let's see.
081.
0.081 divided by 2.
Yeah.
Yeah,
So
0.0405.
0.041.
So that means that our level of significance is 0.05. So what we found was less than the level of significance, which means that the null, we stick with the null, right? I don't know.
Let's see.
The key, okay, the p-value is the area in the tail to the left of the t statistic. So is our p-value then 0.0405?
I think
Is that what
this
it's
sounds
saying?
right.
The p-value is equal. Yeah, I think that's what it's saying. So
So it's
then
0.041.
round to 3 decimal places. So 0.04, yeah, 0.041.
Okay, cool.
So we fail to reject the null hypothesis, right?
Um,
If what we found is less than the level of significance, then we fail to reject.
well, for the p-value, right?
Uh-huh.
So if it's less than it, I think we reject it. I think you fail to reject when it's greater than. Let me look though, just to make sure. If the p-value is greater than the A level, we fail to reject the null hypothesis.
Okay.
So since it's less than it,
So we
we
do reject
reject
it.
it. Yeah.
Okay. God, here's another one. Okay.
I'm not looking forward to doing the homework quiz for this.
Well, it'll probably help after I sit down. It always helps me to sit down and go each problem. I just haven't been able to do it this week, so I'm gonna have to do it Saturday.
Yeah.
I can tell our work is gonna start getting much more difficult.
Oh yeah, for sure.
Okay, let me see. Let me delete the previous stuff and paste in the new. Okay, variable view. Okay. Your first alternative hypothesis is mu is not 40 and use a level of significance of 0.01. What is the p-value? Phone keeps going off. The hospital claims the average time. Okay. So we want the same data.
The p-value.
Do we need the standard? We need the standard deviation and mean and all of that, right?
I think so. The p-value is the area in the two tails beyond the test statistic. T, in other words, the p-value is equal to sig two-tailed. So I think if you did the one sample test for all that information, it would give you the answer. Because
Okay,
it came up as, you saw the like the sigma two-tailed, right?
yes, yeah.
Yeah, so I think if we plugged that in, then it would give us the answer right there.
Okay, and our test value on that one is 40, right? That's what we're testing it against.
Yes.
Okay. Okay, so we need the p-value. It's a two-sided, so it's the significance level, two-tailed, 0.995.
All right.
So at 0.995, we
Fail to reject.
fail to reject. Decide to try another alternative hypothesis. This time you use less than 40 and keep the same level of significance. Did the p-value increase or decrease? Okay, so if it goes to one side, it's going to decrease because we half it.
Okay.
The significance level would be
Yeah.
point
You're right.
oh something, 0.05 something, 0.04. So then in that, well, I guess we need to actually do it to know. Okay, 0.995 divided by 2, 0.49. So that's still above the level of significance,
Yeah.
so we would
So we
still
still
fail to
fail.
reject. Compare the width of the confidence interval for question 11 to the confidence interval for question 13. Which one is wider? Okay. Okay, so do I need to actually figure out the confidence intervals? Or can we figure that out by looking at the p-values?
I thought we could do it by looking at the p-value. I'm trying to read it up.
Let me look back at the textbook. Confidence intervals. Oh, I'm getting a little nervous about our next test now.
Oh yeah.
Construct a confidence interval. Okay, so it's x bar minus t times s over the square root of n. But it doesn't say, I mean, I guess we need a 95% confidence interval. I can do that on SPSS. I'm just not sure that's what it's asking for. Let me see what it tells me. I do 0. Okay, so for 13, that gives us a lower confidence interval of 23.4986 and higher of 56.5966.
Okay.
Then the other one, wait. I don't know if I did that right. Which one is wider? That's probably an easy question. Somewhere in here. How to reject. Okay. No, that's not the answer. I'm looking at the homework answers. And we didn't even do anything with degrees of freedom on this quiz. This is our last question. That's interesting.
Yeah.
Nope, I don't see it on there. Okay, so in SPSS, to do the confidence interval, where is that on here? Analyze, descriptive, statistics, explore. Press statistics, change the percentage. I got that, but I don't know. I guess I'm stuck. How would you indicate the difference in the two questions when you're putting in an SPSS?
Yeah, that's what I'm trying to read right now.
Because 40 is the number for both of them.
So it would be they are the same?
I don't know. So I'm stuck on. Let me play around in SPSS and see. Let me see. I think it has to have something to do with that number that changes. The only thing that changes is the
T-score?
P-score.
Or the P-score?
Because it goes from 0.995 to it would be 0.4975. But how do you indicate that the difference in SPSS, because they're both 40. The number is still 40. It's just that one's one-sided and one's the other. One's 2.
Right. Does it tell you what the t-score is?
Probably. Let's see.
Because if they have the same t-score, then it'll be they're the same. Just looking at the equation.
The t-score for the 0.995 one, which was question 11, the t-score is 0.006.
Okay.
And for the next one, it's 5.048. The big difference.
Yeah, it is. Okay. So let's see.
Okay, is that one of those questions like as something decreases, something else increases? Maybe
That's
from
what
our
I'm
last.
trying to.
Can you throw this away for me? And then, hang on one second.
Oh, you good?
Take those and put them in the recycle. Say hi.
Hello.
How's it going?
Okay, a quick word of caution on something students may get confused on. Using the explore function is the best way to calculate confidence intervals. You may notice that the output for doing a hypothesis test contains a category labeled 95% confidence interval of the difference. This is different from the confidence interval of the mean given in the explore function and will give you different values. So let's see how, I'm going to look at that and see. Explore.
Oh, yeah, analyze and then descriptive statistics to explore.
Explore, okay, and then we'll move the variable over, statistics. I guess we're looking for a 95% confidence interval.
Sounds good to me.
Continue, and then he said in the video to pick plots and do a histogram and a normality plot. And then okay. See what our normality plot looks pretty normal. I don't know. I don't even know if I know what I'm looking for. Okay, so in the says 95% confidence interval. So it's the same thing I said as the 23.4986 and 56.5966.
Okay.
But I still don't get how.
And that's the same for both of them?
I don't know.
Should we just take a stab in the dark?
Yeah, how about it?
Because I don't know if I know enough just from reading this.
Yeah.
I have to do
So,
some the width.
do you think it's wider with the smaller p-value or with the larger p-value? Probably with the.
I think with the smaller one it would be larger.
Wider?
Yeah.
So we'll say.
I could be wrong though.
Well, doesn't matter. I mean, at this point, neither one of us knows. So.
Right. Right.
Okay. So we'll say question 13.
That works.
Wider. Okay, got everything filled out. Let's see. Yes, 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 yes. 3 decimals, 3 decimals. The only one we don't have 3 decimal places on is 6, but I checked that one in, yeah, and 5. Well, no, 5 has 1, but 6 has round to 3, but we only have 2.
Yeah, I think it'll be all right.
And then we're going to submit.
Yeah, 94.
That's pretty good.
Yeah, I'm guessing we got the last one wrong.
We did. They're the same.
Oh
Well,
man.
you know what? That makes sense because all we did was half the one.
Right.
So you'd think that they're the same. It's just that one is one-sided and one is the whole. I don't know. You would think it would be half. Well, anyway, now we know they're the same.
Yeah. That's
That's
good to
not so
know.
bad.
No.
All right. Well, you want to
Oh,
post our link? I have never heard back from Luke at all.
yeah, I'm guessing he
So I'm
dropped it.
guessing he must have dropped the class, but you'd think he would at least email back and say, stop emailing me.
Maybe he likes the emails. I don't know.
Being included. All
Yeah.
right. Well, I'll see you
All right.
Tuesday. Good luck with everything.
All right. Yeah, you
Okay.
too. All
Thank
right. See
you.
ya.
All right. Bye.
Bye.